Welcome to the new session. This is Ranjit Kumar, Math Facilitator. Today we will see the topic pair of linear equations in two variables. This is from class 10th Mathematics. The equation which is in the form of ax plus by plus c is equal to 0 is called as linear equation in two variables. In this equation, we can see x and y. These two are variables. And whereas a is the coefficient of x and b is the coefficient of y and c is constant term. And here the coefficient of x and coefficient of y are both cannot be 0. So this condition can be expressed algebraically, where a square plus b square is not equals to 0. So this equation is called linear equation in two variables. That means two unknowns here. So, first of all, what is linear equation? An equation of degree 1 is called as linear equation. Here the term is degree. What do you mean by degree? The highest power of the variable in the equation is called as degree. So here, if you observe this, the highest power of x is 1, the highest power of y is 1. So, this equation is called linear equations. And it contains two unknowns, so two variables. So, this is called linear equation in two variables. Now, this algebraic equation, it graphically represents a straight line ax plus by plus c is equal to 0 represents a straight line. So graphically it represents a straight line ax plus by plus c is equals to 0. So on this straight line, each and every point is a solution of this equation. A is one solution, B is one solution, C is one solution, D is also one solution. Since a straight line consisting infinite points, so each and every point is a solution of ax plus by plus c is equal to 0. Therefore, ax plus by plus c is equal to 0, consisting infinitely many solutions. Now comes to our topic, pair of linear equations in two variables. Now the name itself indicating pair, so we need to take two equations. So let me write pair of linear equations here. a1x plus b1y plus c1 equals to 0, where a1 square plus b1 square is not equals to 0, and a2x plus b2y plus c2 is equals to 0, where a2 square plus b2 square which is not equals to 0. So these two equations are called pair of linear equations in two variables. So this is also called as system of linear equation. System of linear equation. So as we know that each and every linear equation in two variables represent a straight line. So if we are representing this system of linear equations through graphically, so we have three cases. Let me see those three cases. Case 1. So if you draw two lines in a plane, they may intersect at one point. Let us take, this is line 1, this is line 2. So this I am representing with line 1, this I am representing with line 2. This is a case 1. Now case 2. They may coincident each other, L1 and L2 also on the same line, L2. Both lines are coincident. Now case 3. Both lines do not intersect. So this is L1, this is L2. Yes. These are the only three ways we can represent graphically. In the first case, the two lines are intersecting. So that means it has unique solution. When the system has unique solution, then these linear equations are called consistent. Consistent type of linear equations. So it has unique solution. It means only one solution. So let us take that solution is P, where x comma y are the coordinates of P. Now if we move on to the second case, here the two lines are coincident. So when two lines are coincident, then how many common points will exist? Yes, absolutely. So there are infinitely many common points will exist. So each and every point on the line is solution of this system of pair of linear equations. So in this case, we can say that here it has infinitely many solutions. Infinite solutions. So in this way, this is also called as dependent consistent system of linear equations. Now if you move on to the third case, the two lines do not intersect, so there is no solution. So this type of system of linear equations is called as inconsistent linear equations. So as you observe here, the two lines do not intersect, so here there is no solution. Now how can we identify with the help of this system of linear equations? That means which system has consistent unique solution, dependent consistent, or dependent coincident, or inconsistent. So here let us see the formula. The first one is A1 by A2 is not equals to B1 by B2. This is the condition for consistent unique solution. And the second one, it is dependent and coincident lines. So in this case, this is also called as consistent type of linear equation. Here the condition is A1 by A2 is equals to B1 by B2 is equals to C1 by C2. All the ratios are same. But when you are moving to the third one, these are the parallel line conditions. So the formula is A1 by A2 is equals to B1 by B2 is not equals to C1 by C2. So with the help of this formula, we can identify whether the given system is having unique solution or infinitely many solutions or no solution. So once again I am repeating here, when two lines are intersecting, then it is called as consistent type of linear equations which has unique solution. The condition is a1 by a2 is not equals to b1 by b2. When two lines are coincident, then these are called as dependent consistent type of linear equations. So these two lines are coincident, and here which is having infinitely many solutions, and the condition is a1 by a2 is equals to b1 by b2 is equals to c1 by c2. The next case, third one, two lines are parallel, so which do not intersect here. So this is called as inconsistent type of linear equations and which has no solution. The condition is a1 by a2 is equals to b1 by b2 which is not equals to c1 by c2. So today we learn about the definition of pair of linear equations and how these pair of linear equations we can represent graphically. So thank you for watching this video. I'll come back with another video in the next session. Thank you.